All right, good morning, students. So this is the slide that you saw yesterday, and hopefully you were able to complete yesterday's assignment. I'm giving you today's assignment a little bit later in the day because I saw that more students are active around the afternoon. So hopefully you had a chance to catch up on yesterday's assignment this morning. Now, it's really important that you see today's video because at the end of today, you're going to be doing an exit ticket. And in order to do your exit ticket, you need to know the password. And I'll be saying the password sometime during the video. So that's my way of checking that you're watching the entire video. If you choose to exit this video right now, then you will not hear the password. And if you don't know the password, then you're losing 25 points on today's exit ticket. All right, so this slide says, do you need to catch up on past week's lessons? If you do, then you can click on week 1 slides, week 2, or week 3, depending on what assignments you're missing. But if you're ready to move on, it says click here for today's lesson. So don't click on this arrow, but instead click right over here to see today's, I messed up. It says click here, so click right there, and it takes you to today's lesson. So it says read through every slide, Tuesday lesson, April 14. All right, so our do now, the learning objective says I will learn about the 3 different ways that thermal energy can transfer by listening carefully to the lesson video and taking notes. I will demonstrate my learning and understanding by correctly answering questions on today's exit ticket. So as you watch this video right now, you can take out a piece of paper and take some notes. And if you take good notes, you can use those notes on today's exit ticket. So those of you who choose to be responsible, you can pause the video, write down the notes on a piece of paper, and all of the notes that you've taken, you can use it to do the exit ticket today, which means you'll do much better on today's exit ticket. So again, you can pause the video, get some paper, and take notes as you listen. So what will you submit to me today? You're going to turn in today's exit ticket. It's going to be on Schoology. And when you try to turn this in, it's going to ask you for a password. I will say the password sometime in the video, so keep watching. All right, so it says types of thermal energy transfer. That's the title of our notes. And the first bullet point says heat is the thermal energy that flows from one substance to another due to a difference in temperature. So very important. Heat is not thermal energy. Heat is not thermal energy. Instead, heat is the thermal energy that flows, that transfers, the thermal energy that moves. That is what heat is. And thermal energy always transfers from warmer areas to cooler areas. So for example, this cup is 90 degrees Celsius. That's a type of temperature. And the hand is 36 degrees Celsius. So since this is warmer, since it has a higher temperature, thermal energy will transfer from the cup to the hand. So when you feel your hand getting warmer, you're feeling heat because thermal energy is moving to the hand. And thermal energy transfers, or another way to say that is heat flows from the beverage to your hand because of the difference in the temperatures. So since the beverage is 90 degrees and your hand is 36 degrees, there's a difference in the temperature. They're not the same temperature. And that is why thermal energy will transfer to your hand. And heat is measured as a change in temperature. So how do you know that thermal energy transferred? You'll know when you see that the temperature of both substances has changed. So if thermal energy from the coffee goes to your hand, after some time, the temperature of the coffee and the temperature of your hand, they'll be equal. Both will be the same temperature. And that's how you know that thermal energy has transferred. Of course, the coffee's temperature will no longer be 90 degrees. It's going to decrease. And your hand will no longer be 36 degrees. Your hand is going to get warmer, so it's going to increase in temperature. Now, this is a practice problem. You're going to see the same type of problem on your exit ticket today. So listen very carefully. I'll teach you how to do well on this question. It says 2 solid blocks are heated to the temperatures shown. So there are 2 blocks. This block was heated to 0 degrees, and the other block was heated to 9 degrees Celsius. And then these blocks are placed right next to each other so that they are in direct contact. They are touching. Now, which diagram shows the direction that heat will flow? Which diagram shows how thermal energy will transfer? So if you look here, the arrow is saying that thermal energy will transfer from the 9-degree block to the 0-degree block. This picture says that heat will transfer, heat will flow from the 0-degree block to the 9-degree block. And over here it says that no heat will flow. Heat will not be transferred. Now, which one is correct? Well, you know that thermal energy always transfers from the higher temperature to the lower temperature. So heat will have to go from the 9-degree to the 0-degree since this block is hotter. Next type of question. You'll also see this type of question on your exit ticket. Again, two solid blocks are heated to different temperatures. Block number 1 is 221 degrees. Block number 2 is 147 degrees. The blocks are placed next to each other so that they are in direct contact. Heat begins to flow. Thermal energy begins to transfer between the blocks. Later, the temperature of each block is measured again. Which pair of temperatures is possible in this situation? Well, let's think about it. Block 1 is 221 degrees. Block 2 is 147 degrees. So thermal energy will transfer from block 1 to block 2. Since block 1 is hotter, it's going to go transfer some thermal energy to block 2. Now, if block 1 loses thermal energy to block 2, that means its temperature will start to drop. And if block 2 gains thermal energy from block 1, that means block 2's temperature is going to rise up. So which one shows us a possible result? Well, if block 1 has to lose thermal energy, it cannot be 221 degrees anymore. It has to go down. And if block 2 increases in thermal energy, it can't be 147 anymore. It has to go up. But the trick is block 2 is not going to get as hot as block 1 used to be because they're sharing that energy. So for this answer choice, this cannot be correct because how could block 2 go all the way up to 200 degrees while block 1 drops all the way to 168? That wouldn't happen. Thermal energy always goes from hot to cold, and then once it reaches the same temperature, it stops transferring. So the correct answer would be this one because block 1 will lose thermal energy until block 2 gains enough thermal energy so that they are at the same temperature. Now, there are three types of ways that thermal energy can transfer. The first way is conduction, the second way is convection, the third way is radiation. So we're going to learn about each one. This picture is also on your exit ticket, so make sure you know this picture. Convection, conduction, radiation. I will talk about each one. So conduction is the transfer of thermal energy through direct contact as particles collide. Collide means bump into each other. So like you saw in this video just now, the fast-moving particles over here, they have heat. The fast-moving particles are going to bump into the slower-moving particles, and as they bump into each other, some of the thermal energy from the fast-moving particle will transfer to the slow-moving particles. So that means that the slow-moving particles are going to start to move faster. So for example, when your hand gets hot when you touch a pan, that involves direct contact. It involves touching. The hand is touching something hotter, so then the particles from the pot are going to start to bump into the particles in your hand, and they're going to transfer thermal energy so that your hand starts to get hot too. So very important, conduction is the transfer of thermal energy through direct contact as the particles bump into each other. They must be in contact with each other. They have to be touching. So let's play it one more time. These particles are transferring thermal energy as they bump into the neighboring particles and that's what makes all of them start to move faster. Now, here are some examples of conduction. So when your spoon is inside of a cup of hot coffee, the particles in the spoon are touching the particles in the hot coffee. So that's how all of the particles in the spoon are going to start to get more thermal energy because of conduction. And for another example, if you put ice cubes on a table, the heat from the table is going to transfer to the ice cubes through conduction since there's direct contact. The ice cube is touching the table. Again, your hand touching a hot pot, and like the coffee example, when your spoon gets warmer after sitting in a bowl of soup, that's because the particles in the hot soup bumped into the particles in the colder spoon, and then it transferred thermal energy through conduction. The second type is convection. Convection is the transfer of thermal energy by the movement of fluids. So this doesn't involve solids. This is talking about fluids like a liquid or a gas. And it's a known fact that warmer fluid rises up and the cooler fluid sinks down. So for example, when you boil water, the warmer water on the bottom near the fire is going to start to rise up, and the cooler water is going to sink down, and then it's going to heat up, rise up, sink down until the whole bowl of water is hot. So let me play this video. So there's fire right over here, and it's heating up the water particles here. Oh, there was an error. Okay, we can't play this video. I'll have to show you something else. But if you look over here, as the water warms up, it's gonna rise up, and as the water on the top, since it's cooler, it's gonna sink down, and as that keeps happening, the entire pot of water will get warmer. So that's convection. One more time. In a warmer fluid, the kinetic energy of the molecules increases, the molecules move faster, they spread out, their density means like how much mass there is in a certain space. So since they're all spread out, they're going to be less dense, they're going to decrease, and kind of like they will weigh a little less, and that's why the fluid will rise up. But in cooler parts of a fluid, the kinetic energy of the molecules decrease, they move slower, the molecules are closer together, they're not spreading out. This means they're going to have a greater density. They will kind of be heavier, and that's why the fluid sinks. So again, that's why hot air in a hot air balloon is able to rise up, and that's what makes the hot air balloon rise all the way up, because as the fire is heating up the air over here, the hot air will rise up, the cool air will sink and get heated, and it's just going to keep going up. And even in a heater, the warm air by the heater is going to rise up, and then as it cools down, it's going to sink down, and then it's going to go through the heater and get hot, rise up, and sink down. So again, convection is the transfer of thermal energy by the movement of fluids like liquids and gases. Warm fluids rise up and the cool fluids sink down. Okay, last one, radiation. Radiation is the transfer of thermal energy through space by electromagnetic waves. So through space means that it does not require matter. So this is different from conduction. That you don't need to have direct contact. You don't need the two substances to be touching in order for thermal energy to transfer through radiation, because radiation involves electromagnetic waves. These are like the squiggly lines, the squiggly arrows that you see. So for example, how does the sun bring heat to the earth? Well, the sun is very, very far away from the earth, but thermal energy from the sun is able to transfer through radiation, through these electromagnetic waves. And even a hot fire, if you stand near the fire, your hand is not touching the fire, your body is not touching the fire, but thermal energy from the fire can transfer to your hand through these waves. So again, radiation does not require matter. It does not require the particles to be bumping into each other like conduction. And here are some more examples. Again, your hand heating by the fire, the sun heating up the inside of the house, and even a microwave. When you put food in the microwave, how the food heats up is through radiation. So here's your summary page. Again, if you want to write this down so that you can use this for your exit ticket, you may. You can pause the video and take some notes. And again, this picture, now it should make more sense. The fire is transferring energy through radiation, these waves. The water is getting hotter because of convection. The hot water down over here by the fire is going to rise up. The cold water is going to sink down, and it's going to keep rotating and cycling until the whole pot of water gets hot. So that's convection. And your hand is going to get hot through conduction because the pot is getting hot. So the hot particles in the pot are going to collide and bump into the particles in your hand and transfer thermal energy. All right, so now you're ready to go and take your exit ticket. So when you try to do this exit ticket, it's gonna ask you for a password. And since you watched the entire lesson video for today, I will say the password right now, and you're going to type the password into your exit ticket. And you must answer each question very carefully, and you have 2 chances to earn an A. And it is worth 25 points, so please take it seriously and try your best. All right, so the password is radiation. Make sure you spell it correctly. The password is radiation. How do you spell radiation? You can look over here, radiation. It's not capitalized, just type in radiation. So let me type it over here for you. The password is, you're going to type radiation when you get to your exit ticket. All right, so let me show you on Schoology. When you go to your science class for Schoology, it's going to say exit ticket, types of thermal energy transfer. You're going to click on that, and it's going to say this. Read this. When you press start attempt, it will ask you for the password. I just told you the password right now. So you're going to type in the password and take the exit ticket. If you didn't watch the video, then you shouldn't take the exit ticket just yet. So you'll press start new attempt, you're going to type in the password and then turn in your exit ticket to me. All right, if you don't feel ready to take it yet, you can go back and study the notes again.